Alright, so here I'm going to teach you about a little device that's kind of fun. This is a servo motor, and so there's a lot going on here, so I'm going to try not to overwhelm you too much, but it has 3 wires that we can connect it to. So the first one here, if we hover over it, this is our, I don't know if it'll tell us. So this is our signal wire, and then this one right here is the power. And this one is ground. So 5-volt, ground, and signal. And you can see they're colored. So red is 5-volt, brown is ground in this case, or negative, right? And then this orange one is the signal wire. Okay? And so if we come down here, we can see I've got the signal one connecting here to pin 8. And then something weird happens here. So I've got the 2 wires there. I've got connected to this device, which is an electrolytic capacitor. And we will get into capacitors later, but this is serving as a charge reservoir, and so when this motor first starts moving, it draws a whole bunch of current, and so to help us provide that current without taking all the power away from the microcontroller here, we have a capacitor, and it provides like a little safety net essentially, and probably like generally you don't want to directly control a motor from this device. But because this is a very low current device, it's okay, and it's not under any kind of load. But sometimes when we're controlling servos like this, they'll act kind of funny just because they're drawing a lot of current and it interferes with the way that the microcontroller works. So anyway, we've got our 3 wires, 2 of them connected to the 5-volt and the ground, also connected to this capacitor that's going to help us kind of keep that power level constant when it changes. And then we have this one right here connected to pin 8, which is going to be our signal. Okay, so now let's go ahead and take a look at the code to operate this device. Okay, so what you see here is a very simple program to operate a servo motor. And this is just to kind of show you some of the basics of it, and then you'll be able to kind of mess around with it from here. And so a couple things. First of all, this line here is a little bit different than anything we've seen so far. And what it says is the pound include. This is what we call a preprocessor directive, and it's going and finding this document that has all the functions for controlling the servo in it. And more specifically, there's some kind of advanced C++ object-oriented stuff going on here, which isn't something we need to know, but it would actually have the class definition of the servo there. Okay, so anyway. We import this header file, which gives us the capability of using the servo motor. And so if I compile this, you'll see that there's no errors because I'm allowed to use these servo functions. Okay, and you can see down here that it verified successfully. If I were to eliminate this line, I would run into errors when it compiles just because it doesn't off the bat know these functions. It has to so you can see servo does not name a type, didn't you mean serial? So it doesn't know what I'm trying to do here because I haven't included that library. So if I include that library, we're all good. And so we include our servo library, and then we start by creating a servo object. And so we create, or an instance. So we create an instance of a servo. And this is useful because we can actually make multiple servos. We can call it servo 2, and we can control them separately, individually, however we want. And then we come down here and we could say, okay, on line 15, I'm going to attach a servo to pin 8. And so that's basically saying this servo object that I created is going to be attached to pin 8. Okay, and so there's all kinds of code in the background that's running when I call these different functions. And it's basically saying when you call servo functions, you're going to call them on pin 8, okay? And so we're going to send the servo code to pin 8, or the servo signal, I suppose. And then here on our loop, we have something called servo.write. And so we need to, at the beginning, we need to attach our servo, initialize it basically, tell it it's on pin 8, and then we need to write our servo and control, essentially we're controlling its position, and we can control it anywhere between 0 and 180 degrees. Now these are pretty low cost servos, and they're kind of cheap little hobby type servos. We can do lots of fun stuff with them, but they lack some in precision, as well as the way that we're powering them. They might not be getting as much current as they want, and so sometimes they don't quite act the way that we want them to, but we can still get a fair amount out of them if we understand these functions. So anyway, that we see this code here, it's going to write it to position 0, it's going to wait for a second, it's going to write it to 180, it's going to wait for a second, and it's going to repeat again, going between 0 and 180 over and over indefinitely. Okay, so let's go ahead and see what that looks like in the simulation. Okay, so we've got the code here. We're going to start this simulation, and so we can see that when I press go, you see that servo rotating back and forth between 0 and 180 degrees. Okay, and it looks like it might not quite be getting all the way there. Okay, and so one thing we could do is, it does take time, so we could probably increase the length of these delays and see if that makes a difference, if it's able to get to that full position, that full 180 degrees. And there we're getting a little bit better position, right? We could even see if 2 seconds. And so this is obviously, there's a challenge here in the fact that this is a physical object and it takes time to reach the position it wants to get to. Okay? And it looks like we're kind of capping out maybe not quite 180 degrees. And so you can see, again, there's some limitation there, but you kind of get the ideas. Okay? And you can adjust those. Let's say you don't want to have that full range. Well, you can change these angles, right? We don't have to go all the way down to 0. We could go to, say, 30. We don't have to go all the way to 180. We could go, say, to 120. We can run that simulation, and you could see that it's going through a smaller range of values, kind of going back and forth. Okay? And so anyway, this is a servo motor, right? And so if you want to, have fun with it, you can then start to connect it maybe to an input from some type of sensor, right? Maybe you have an analog sensor and you're mapping that input from the analog sensor to an output value on the servo. Okay. Maybe you have a button and you press the button and it turns to a certain angle. You press a different button, it turns to a different angle. Or while it's pressed, it goes to here. When you let go, it goes to there. Or every time you press it, it has a different set angle it goes to. There's lots of different ways you could have fun with this and do different things with it. Okay, so this is a servo motor. The key takeaways here is we have to include our servo library. We declare a servo object. We attach our servo to our pin. Here we have it on pin 8. And then we have our servo write, where we can control what angle it's going to. And so this is based on the name that we gave it. Here and here is based on the name that we gave it when we created that object up here. So if we want to call it something else, my servo, then we would just come through and change it here, here, and here, and everything would work exactly the same. Okay, so here's the basics of the servo, and then we wire it with that capacitor here. That little gray strip on the side represents negative. Okay, and yeah, here's your servo connected.